Assalamu alaikum everyone. I hope you guys are doing well. There was slight delay. I sent you a couple of files to review. वो please देख लीजिएगा. Assalamu alaikum. I'm good. I'm good. Thank you so much. Walaikum assalam Ahmed, Haroon, Abdullah, Rabia. Good to see you all here. I have no idea what the next person is. Ji Abdullah, do you have anything to add? No, I'm not ignoring you. Don't worry. Yes, शुरू कर लेते हैं इंशाल्लाह. अभी कर लेते हैं. Let people come in. अस्सलाम वालेकुम समिया. अस्सलाम वालेकुम उमर. I sent you a couple of what you call uh, files and two mock exams. I made them like long ago, but I forgot to share them with you. So I wanted to, but I forgot. So I hope को बहुत ज़्यादा मसला नहीं होगा. You can still attempt them if you feel like, or attempt just one of them. Okay. Assalamu alaikum Emil. Assalamu alaikum Samia. Can you send them again? Sure. They are in the rapid revision group. If you're there, you should be able to get them. थोड़ा सा ऊपर चले गए होंगे क्योंकि there have been lots of discussions in that group. So I'll just wait for a couple of more minutes and then we'll start. हमारा मकसद obviously आज ये है कि आज ATP review हो जाए. अस्सलाम वालेकुम राबिया. Do we write white PPT or lime water turns milky? I've seen lime water turns milky as a good enough explanation, but you can write white precipitate. That's also acceptable. Examiner दोनों को mark करता है और दोनों को correctly mark करता है. I guess we are seeing it. Hold on. Yeah, we should be able to see the session now. Yep. Board सबको नज़र आ रहा होगा या? All right, let's begin now. So the first thing in ATP, time management is super important because time कम होता है इस पेपर में. Also इस पेपर में आपको periodic table नहीं given होता, which means that you need to memorize the colors, you need to memorize many important things like कि halogens में कौन कौन से आते हैं, noble gases में pattern क्या है उनका for group 7, क्योंकि displacement के ऊपर question आ सकता है लेकिन आपको periodic table नहीं given होगा. So you need to know the halogens at least, और group 1 को भी याद करना मेरी तरफ से मैं तो recommend करता हूँ कि आप कर लें क्योंकि आपको displacement reaction में पूछ सकता है कि कौन सा किसको डिस्प्लेस करेगा. यूजुअली सोडियम और पोटेशियम के बीच में आता है या क्लोरीन और ब्रोमीन, क्लोरीन और फ्लोरीन के बीच में आता है. सो इट्स FCl एंड देन Br. सो ये छोटी सी दो चीज़ें हैं जो आपको पता होनी चाहिए कि periodic table ना हो तो क्या होता है. सिमिलरली ट्रांसफर मेटल्स में हमारे पास कुछ ट्रांसफर मेटल्स हैं जिनका हमें याद है, जैसे कि जिंक इज़ नॉट अ ट्रांसफर मेटल तो हमें याद है कि वो +2 है, या स्कैंडियम इज़ +3 हमें याद है, सिल्वर इज़ +1 ये भी याद होना चाहिए. But other than that, iron +2 is green, iron +3 is red. ये चीज़ें आपको पता होनी चाहिए. बाकी ATP के पेपर में आपको पता है कि देयर इज़ शॉर्ट आंसर एंड क्वेश्चंस, तो आपके पास शॉर्ट आंसर देने की जगह होती है. यूजुअली स्ट्रक्चर क्वेश्चन में डिज़ाइन वाले क्वेश्चंस आ जाते हैं कि आपको लैब apparatus का पता है कि नहीं पता, या उसके अलावा डिटेल्स होती हैं, और इसके अंदर क्वालिटेटिव एनालिसिस के नोट्स गिवन नहीं होते. ठीक है. एग्ज़ाम इज़ ऑफ 60 मार्क्स दिस ईयर, उस नेक्स्ट ईयर से वो चेंज हो रहा है, बट फॉर दिस ईयर इट्स 60 मार्क्स, लेकिन उसको वो स्केल करेगा, उसको वो 30 पे लेके आएगा, जिसका मतलब है कि आपका जो 2 मार्क्स है ना वो एक्चुअल में 1 मार्क को काउंट करते हैं. तो इसका मतलब है कि आपने डिटेल में इसके आंसर्स देने हैं क्योंकि एग्ज़ाम में तो वही 2 मार्क्स ही हैं. ऑलराइट जी, इंशाल्लाह कोशिश यही है दैट टुडे वंस वी आर डन विद दिस सेशन we should know and everything we need to know about ATP. अस्सलाम वालेकुम सामी, काफ़ी वक्त हो गया आपसे बात नहीं हुई. Good to see you. All right, and who's awesome? Okay, I think we all are. All right जी, अब अब्दुल्ला का कमेंट हम ना पिन कर लेते हैं. बिकॉज आई गेस क्लास में आ गई है, सारे आ गए जी. तो अब्दुल्ला सेड दिस व्हेन ही जस्ट जॉइंड इट, सो या आई अप्रिशिएट द सपोर्ट, थैंक यू. अच्छा चलो लेट्स स्टार्ट. पहली बात, हमारे पास जो याद करने वाली चीज़ें हैं वो साथ साथ आती जाएंगी, एंड आई विल ट्राई कि जो भी उसमें याद करने वाली बातें हों वो साथ साथ मैं आपको बताता जाऊँ. सो विल क्विकली गो ओवर कि हमें क्या क्या याद करना है. ऑब्वियसली हमें पीस एपरेटस का पता होना चाहिए. एपरेटस से स्टार्ट करते हैं. सो द एपरेटस दैट वी हैव, हमें लैब में जो चाहिए होता है उसकी ड्राइंग करना आपसे वो नहीं पूछेगा. यू मे ड्रॉ अ ड्राइंग आएगा, और मे ड्रॉ अ डायग्राम. उसका मतलब ये है कि ड्रॉ करो. इफ दे से यू मे, दैट मीन्स यू शुड. Alright, they've given you space for a reason. Why not make use of that? Also, if you use it, always label the diagram. कभी भी diagram without labeling नहीं छोड़नी. Alright? Alhamdulillah. Sorry. Sorry. Yeah, so anytime you are drawing a diagram, make sure that you label it as well. खाली label किए बगैर diagram नहीं देनी. Also, do not spend too much time on the drawing or the labeling, because it's not really required. आपके exam में drawing का exam नहीं है, diagram की quality का exam नहीं है. It is the important things that are there or not, उसका exam है. So हम apparatus में will start with. What do you mean? Did you start pausing? I don't understand that. हाउ लॉन्ग विल बी द स्ट्रीम? आई एम अस्यूमिंग कि 2 घंटे हम कर लें. 2 घंटे शुड बी गुड इनफ. और अगर काफ़ी ना हुआ तो आई ट्राई कि हम 2 घंटे में कोशिश है कि सारा हो जाए. सो लेट्स गो ओवर. सो हमें सबसे पहली चीज़ है कि टाइम को मेजर कैसे करते हैं. तो टाइम को मेजर करने के लिए वी हैव स्टॉप वॉच. ठीक है. एंड स्टॉप वॉच, एज यू नो, इज़ यू डोंट नीड टू ड्रॉ इट. एक सर्कल बना लें ऐसे, ये जी स्टॉप वॉच है, लेबल करते हैं इसको. ठीक है. दिस इज़ अ स्टॉप वॉच. ठीक है. बहुत ज़्यादा टाइम इस पर लगाने की ज़रूरत नहीं है. ये ले जी, दिस इज़ एन एनालॉग stopwatch. You don't have to draw it. You can put the other one there. डिजिटल हो सकती है. तो ऐसा चीज़ की डायग्राम वो इतनी ज़रूरी नहीं है. बट यू नीड टू मेंशन कि आपके पास स्टॉप वॉच होनी चाहिए इफ़ यू आर मेजरिंग द रेट, और उसमें टाइम का इंपॉर्टेंट फैक्टर होता है ऑब्वियसली. देन वी हैव थर्मोमीटर. थर्मोमीटर हमारे पास, द थर्मोमीटर दैट वी विल यूज़ विल बी द ग्लास इन मर्क्री इन ग्लास और एल्कोहल इन ग्लास, लिक्विड इन ग्लास थर्मोमीटर्स. तो आप उसमें सिंपली ये ड्रॉ कर सकते हैं. यू कैन से कि ये थर्मोमीटर है, बस उसको लेबल करना है आपने. यू डोंट नीड टू ड्रॉ वेरी एक्यूरेट पिक्चर्स. उसके बाद आ जाता है कि मास को मेजर कैसे करते हैं. तो मास के लिए वी हैव बैलेंस. ठीक है. एंड बैलेंस भी अगेन इट्स जस्ट दिस ट्रेपीजियम, दैट्स गुड इनफ. ये आ गया तो ये हमारे पास बैलेंस है, एंड दैट्स गुड इनफ. वी डोंट नीड टू ड्रॉ अ लॉट ऑफ डिटेल. अच्छा, जब भी इन चीज़ों को मेजर करते हैं तो यू हैव टू नो दैट इट्स ऑलवेज सम चेंज दैट वी मेजर. इट्स नेवर कि अच्छा टाइम स्टॉप वॉच को चला दिया. ऑब्वियसली 0 से शुरू करेंगे तो जितने टाइम के लिए वो ऑन हुई है उसको देखना है. सिमिलरली थर्मोमीटर है, तो थर्मोमीटर की जब भी वैल्यू आपने लेनी है, यू हैव टू फर्स्ट नो कि आपकी रूम टेम्परेचर की क्या वैल्यू है. सो दैट मीन्स कि फर्स्ट whenever you're saying use a thermometer, start by first also telling के note down the room temperature value, and then उसके बाद आपने अगली जो भी whatever the value comes out to be after heat it or after you cool things, that's the new thing that you have to know. Hopefully 2 hours. That's my plan to keep this lesson for 2 hours. Similarly for maths, you have to make sure कि initial mass 0 हो. अब sometimes what we do is we don't just put things on the balance. We put them in a beaker, or we put them in some glass, some petri dish or some china dish. So you have to make sure कि आप mention करें that put the china dish on the balance, read the value, then add the mixture or add the solid to it, and then subtract it to know the mass. That's also important. I'll be going over the whole of ATP inshallah. Yes Dada, we are going to see the colors, and we are going to know how to find different colors and all that. I did make a video on that, but I will have to look for it, और मैं आपके साथ share कर दूँगा. But of course in the end of the lesson we will hopefully review that as well. Okay, so that is how you figure out the mass. So you have to know that whenever you're measuring any value, you are reading any value, you are getting 2 values, the starting value and the ending value, and you're subtracting them. So it's never time, it's never thermometer key reading, it's never just mass. It is the difference in those values that we consider for all our reactions and all that. Similarly, we have gas volume. In fact, volume can be of gas and volume can be of liquid. And whenever you're doing that, you have to make sure there were different things of measuring the volume of liquids. For gas, we just have this, the gas syringe. And whenever you're drawing the gas syringe, you have to make sure that, sure, this is a very simple way of drawing a gas syringe and we connect it with something like that. But this gas syringe right now is useless for measurement. That's important to remember. It is useless when it comes to measurement right now. Yes, I will cover the experiments. Only if you draw these small lines, they may seem small, but these are called graduations. And these are important because without these, this gas syringe will not be able to measure the value. So you have to mention that we must measure the value whenever we are going to do that. All right, so that is done with the volume of the gas. Now let's move on to liquids. So whenever you're measuring the volume of liquid, we have many different things. So we have a beaker that is there. We have a measuring cylinder, which is again there. Okay, and measuring cylinder has these marks. Beaker might also have these marks. Then we have pipette. So pipette is something that usually has this kind of setup. And then we have, and it has just one mark. And then we have the burette. Burette has a tap. So that is the tap there. And then there is also different markings there. And burette is the one that's there. Notice that as I move towards the right, the precision increases. Okay. So, and you'll notice that the narrower the bore, more precise the thing. So that's another important point to remember, that if you have a very open container, it will not be as precise as the one with a narrow opening. Similarly, in this one, beaker is used to store liquids for a longer period of time. Measuring cylinder is used for measuring them and just transferring liquids. Acha. Sometimes in titration, for example, they may give you the measuring cylinder, as I think they did that in 2019, sorry. And they might ask you, okay, acha, isko transfer kiya, is that a good idea or not? So remember, the best way of transferring liquids is by using a pipette or by using a burette. Burette and pipette are equal when it comes to their precision. They both measure to 2 decimal places. For example, burette की reading पे भी आप 25.00 ले सकते हो और इस पे भी आप 25.00 ले सकते हो. Okay, now here's an important thing to remember. The first three here, they measure the liquid inside. Okay, so these measure liquid volume inside them. And this measures the liquid volume that has been taken out. Assalamu alaikum, Zain. So that means when a burette is full, it will read 0. But when you take the liquid out, that is the value that you're going to get. So if the burette says 10 cm cube, that shows that it has lost 10 cm cube or 10 cm cube has been taken out. So in the exam, they might ask you to read values from different containers. Now you have to remember that in the ones that have liquids inside, we read from bottom up. So that means if there is a liquid in the measuring cylinder that is at this value, you will read the value that is here. So this is the value that's here, and this goes up and it is higher value that is above it. Okay. But in the burette, the higher value is below it. So if they give you the reading like, if this is the reading, then that means you're reading the value here, which is the telling us that all the liquid that has been taken out. So it is not telling us the volume that's inside, it's actually telling us the volume that has already been taken out. So that's the primary difference between burette and the rest of the containers. So burette is used when you want to add a liquid in known quantities, like in titration. But pipette is the best choice if you want to transfer them. Assalamu alaikum, Fahad. Assalamu alaikum, Zainab. Now let's move on to different kinds of flasks. So Zainab, your question will also be answered in this. So there's 3 categories of flasks that we will use. There's the one that is called conical flask, then there is a boiling flask, and then there is a volumetric flask. Now remember, I told you, narrower the bore, more precise the thing. And volumetric flask in these is the most precise. Now, what are the uses of these things? This is used for mixing. This is used, as the name suggests, boiling, which means you can heat it. and this is used for diluting. Okay, so these are the three different flasks, and we should mention these. Assalamu alaikum Shiza. Yes, hopefully this will be available after the lessons over. So this one is conical, this one is round bottom or also called boiling flask, and this one is volumetric flask. Now the difference is that volumetric flask is the only one that is used to measure a fixed value. The other two, they are not really used for measuring the values. They're more like conical flasks for mixing different things. For example, in titration, we mix acid and alkali in conical flask because it is easier to mix them. It is easier to swirl it. By the way, if you're enjoying the class, then like the session and invite your friends if you have any. Then round bottom flask is good for heating things, and volumetric flask is for diluting, which means that if you have some liquid, for example, you have 10 cm cube of a liquid and you want to increase the volume to 250, then you might want to use a volumetric flask or 250. अब volumetric flask 250 का करने का फ़ायदा क्या है? उसका फ़ायदा ये है that you have diluted it. You have changed the concentration. Remember, you have changed the concentration. Okay? It's okay यार, हम होता रहता है, कोई मसला नहीं. So one thing that does not change in volumetric flask, that is number of moles. So that's a very important thing to remember. In fact, this is super important for O levels people because it is not in IGCSE. It is only in O levels where they test it. In fact, there have been some discussion on the teachers forum जो Cambridge के साथ होता है, that we should take this out of the syllabus for the next year. But खैर वो तब देखेंगे. So right now, this is number of moles before diluting is the same as number of moles after the dilution. That's a very important point to remember क्योंकि जो आपके पास moles के questions आते हैं, in those questions they do take this thing that alright, we had 25 cm cube of something, we added it to a volumetric flask, made it up to 250. Then we took 25 of that and then we did some titration. So then they tell you the moles in that 25, the one that you got from the volumetric flask. Then they ask you to figure out the number of moles in 250. Now remember, if you take something out of the diluting out of the volumetric flask, the number of moles will change. When you take things out of the volumetric flask, number of moles will change. So for example, if you take 25 cm cube from the volumetric flask, then let's say that has number of moles 0.05. Then volumetric flask will have 250, so the volume is 10 times, moles will also be 10 times. Okay, so if it was 0.05 outwards, it will be 0.5 inside. But the one that was before the volumetric flask, it will have the same moles. So if there is 0.5 moles in the volumetric flask, in the 250 that it has, then that is the same number of moles that is in the one before the volumetric flask, before you added water. बात simple सी है, you've just added water when you added things to a volumetric flask, moles तो उतने ही थे, उतने ही particles आपने पहले 25 में रखे हुए थे, अब आपने वो 250 में कर दिए, number of moles remains the same. And that is something which is usually the G or the H part in the volumetric analysis question in ATP. Other than that, you have round bottom flask, which is used for heating them, and conical flask, which is used for mixing. Usually we use the mixing part for titration and the round bottom flask for distillation, and one more thing which is called reflux. So there are two uses of round bottom flask that I'm going to show you. The first one is distillation, which is pretty straightforward, that you heat things that you want to separate in this. So आपने उसको separate करना है, you're heating them, they have different boiling points, you use it. You can use this boiling flask with many things. So there, one thing that we use it directly with, sorry. So one thing that we use it with is called, so I can use it directly, I can join it to a condenser, and that condenser like this, okay? So if I do that, this looks like a stomach, and I put a thermometer here, that will give me whatever liquid I'm looking for, and I heat this thing. Now a couple of things to remember here. First of all, where should the thermometer be? Thermometer should always be at the level of where the liquid is going out. Okay, so that's important. Liquid जहाँ से बाहर जा रहा है, That is where the thermometer should be. It shouldn't be at the top, it shouldn't be below it, it should be right where the liquid is going out, because you want to measure the temperature of the vapors going out. Similarly, this condenser, where should the water come in? Now, here's a very easy way of remembering this. Wherever you want the liquid to come out, that is where water goes in. Water goes in where the liquid comes out. So here the liquid is coming out from here, right? So there's the liquid coming out from here. Sorry, what is it doing? Yeah, so liquid is coming out here. That means water will go in here. All right, so water goes in here and water goes out here. Aram, pay attention. Similarly, you have heat source के ऊपर भी अभी बात करता हूँ. Now the second thing we can use the round bottom flask with is not to just connect it to the condenser directly. We might want to connect it to what is called a fractionating column. Now this fractionating column is used when you want to basically separate two liquids that are miscible, that have this, they mix together and they use the same, they're in the same setup, but they have difference in boiling point. So we heat this thing. So we can connect the round bottom flask with the condenser directly for simple distillation. We can connect it to the fractionating column for fractional distillation. And then the third case, and this is a very important case, it has been tested 2 times in the last 4 years. Okay, पहले नहीं होता था इतना ज़्यादा. That is reflux. When you use round bottom flask directly with the condenser. Okay, when you use the round bottom flask directly with the condenser, that is called reflux. Now, why do we use round bottom flask in particular? I think it's easier to put it on the tripod stand, and conical flask is easier to, it has a broader base, so it's easier to like swirl it around, and it has a narrow neck, so it's easier to do that. With round bottom flask, I think it has something to do with the spherical shape, that it transfers or distributes heat energy better. And it's also usually made of a different kind of glass that is much more, that can withstand heat to a higher level. Anyways, they will not ask you about that. Acha, ab yahan par what have we done? We have used the reflux condenser, which is used for reacting, this is used when you're reacting, reacting volatile liquids. It's a very important thing to remember because examiner iske upar पूछता है. I don't know what's happening with you, Haroon and Abdullah. Okay, that number can mean many different things. Some are even religious, so I don't know what your point is here. Acha, reacting volatile liquids का मतलब क्या? I'll give you an example. When we want to oxidize alcohol, we know alcohol is volatile. So if I heat it, it will just go away. But if I don't heat it, it will not react. तो मुझे heat भी करना है, and I want it to react as well. So what do? I will put it with KMnO4, for example. It will give me carboxylic acid, right? That's good enough. But if I just let it be, it will evaporate, it will not react. So we will need to heat it. But if we heat it, there's a higher rate of evaporation. So we take the condenser. What the condenser is going to do is that if there are going to be some vapors that go out, the condenser will send them back in. तो मैंने आपको बताया था that wherever the liquid comes out, that's where water goes in. So because we want the vapors to come back into the flask, that means water will come out in here. And it's usually a 1 or 2 mark question that is going to be asked in the exam. So that is the third thing we can use with the round bottom flask when we want to heat things or when we want to condense things. And this is the reflux setup which they usually ask us for. Now let's quickly talk about the sources of heat. Thank you, Abdullah. But I think it is probably on. I'm not sure. But it doesn't matter. Pardon everybody. Alright, so sources of heat that we have, there's primarily just one source that you need to particularly know about, which is when to use electric heater or hot plate. Now we can use electric heater or hot plate any given day. We can use it for any kind of reaction or any kind of heating process, because we don't really have to there's no particular reason why you can't use it. But there is Bunsen burner, which is cheaper, easier, and much easier to handle, and it also provides much higher levels of temperature. So we cannot use that if we have flammable substances. So electric heater and water bath. In fact, water baths shouldn't just be called water bath. We say thermostatically controlled water bath. Now these both offer a greater amount of control. Okay. Now thermostatically controlled simply means that you can control the temperature that it provides. So for example, if you're doing a reaction, and in that reaction, remember, we sometimes say that temperature should remain constant. So these are the two things we can use to do that. Okay, so thermostatically controlled thing is important if you're, for example, doing a rate of reaction question in which they say, okay, what should be kept constant, and you write temperature. How do you do that? By using thermostatically controlled water bath or electric heater. Bunsen burner does not have that advantage. The Bunsen burner provides a lot of temperature, but it provides that without offering a great deal of control. So then we have Bunsen burner. So when do you use these two things? Two circumstances. You use these when either you have flammable substances, okay, which is also called inflammable. Okay, remember that flammable and inflammable mean the same thing. And the second thing where we need to use them is called when you need to control the temperature. Okay, so these two circumstances are where you will definitely use these, but Bunsen burner is the one that you use in other cases. Similarly, in this situation where you're using water to heat them, or when you're using water to heat them here, you have to know that if the temperature is beyond 100 degrees Celsius, water will not be able to cool that thing. Okay, because water will boil itself. So that's also another thing they can test you on, that this particular thing boils at 140, for example. Then can we use this setup? We can't, because water which is supposed to cool it will also boil away. ठीक है, अब आ जाते हैं कि हमें ये उसने सेटअप बता दिया, ये सारे these things that we use. Now, what are some useful ways of separating things? Okay. And how can we make sure that we know the setups that are required? So there's two main chapters that deal with this. One is separation techniques and one is rate of reaction. इन दोनों के setups आपको draw करने आने चाहिए. In fact, salt analysis का भी आना चाहिए. Okay, but we'll get to that later on. All right. So let's quickly go over the separation techniques thing. Now, separation techniques thing is really easy. We will separate things based on what state they are in. So guys, what's going on in the chat here? So we have solid plus solid. If you have two solids, how do you separate them? Okay, so you have to make sure that if you're going to separate two solids, then you cannot separate them right away. Okay, you have to make sure that if you are separating two solids, then you will need to first mix them and make some mixtures. Okay, that will be some solution, some way to separate things. Okay, that's an important thing to remember, that for example, if you're going to use, for example, salt and sand, remember that example. Salt and sand के साथ कोई obsession नहीं है examiners की. Okay, it is just that salt is a very good example of things that are soluble and sand is a very good example of things that are insoluble. So the only way to separate these two things is to first dissolve. Okay, so you first dissolve them, and after you dissolve them, you basically separate them out. Okay, and how do you do that? you have to know that if one is soluble and one is insoluble, then the only, in fact, there are two ways of separating them, but examiner kya karta hai? If you have a solid and if you have a mixture solution, examiner will separate only, examiner will only accept filtration for that. Decanting, जो हम usually 9th grade में पढ़ते हैं, it is not acceptable in ATP because it's not a perfect method. So if you want to separate them, you dissolve, then you filter. Okay? So what will happen then? If it is soluble, it will come out in the filtrate and you will crystallize it, or you will basically dry it out as a powder. If it is part of the insoluble thing, then it will be coming out as a residue, and then you wash and dry it out. So let me explain again. If you filter this, you will have either the filtrate, obviously, or the residue. Now to get the filtrate, you have two options. So what you'll do is you'll say filter the liquid. That's good enough. You don't need to give बहुत ज़्यादा detail नहीं बतानी कि अच्छा फिल्टर पेपर लें, कोनिकल फ्लास्क लें या कोनिकल या वो फिल्टर फनल लें और उसके ऊपर उसको रोल करके रखें. You don't need to show any of that. Examiner को पता है कि filtration setup क्या होता है. Unless they ask you for details of that, you don't need to mention. Just say filter the mixture. That's good enough. And then from the filtrate, you have two choices. You either need a powder or you need crystals. अब मैं आपको बता देता हूँ कि crystals को separate कैसे करते हैं. So if you want to get the filtrate, you heat to crystallization point and slowly cool. All of this will give you 1 mark. Second point, in fact 2 marks, because you have to heat it, and then second point is for crystallization point. Crystallization point is also called saturation point. And the second point that you must remember, और बहुत से बच्चे इसको भूल जाते हैं ये लिखना है, that is dry the crystal in folds of filter paper. You have to dry the crystals once you get them, because you have to make sure that only water crystallization is there. If you want to get just powder, then what do? Then you have to use this thing, heat to constant mass. This is important. Again, this is worth 2 marks because you are heating it and you're getting the constant mass. That's an important term to remember, because you're making sure that not only water but also water of crystallization goes away. So this is what you do in this case. If they ask you for filtrate, which is soluble, remember this, the soluble solid comes in the filtrate, and you have to mention how do you separate out. By, if you're getting powder, then you heat to constant mass, which you don't need to dry, it's already dry. And if you're crystallizing, then heat to crystallization point and then dry the crystals in folds of filter paper. Even if you don't say कि अच्छा slowly cool, वो भी ठीक है. Residue is usually the insoluble solid. ठीक है. और जब भी आपने नाम लेना है, जब भी आपको एग्जाम में क्वेश्चन आता है, यू हैव टू नेम द थिंग, बिकॉज दैट इज हाउ यू नो एग्जैक्टली, और एग्जामिनर नोज एग्जैक्टली कि बच्चा किसकी बात कर रहा है. सो इनसॉल्युबल सॉलिड, इफ यू वांट टू सेपरेट इट, देन यू ऑलवेज वॉश. ओके, सो वॉश विद डिस्टिल्ड वाटर. डोंट से वॉश विद वाटर, ईदर से वॉश और से वॉश विद डिस्टिल्ड वाटर. वॉश विद वाटर पे कोई मार्क्स नहीं मिलते. वॉश विद डिस्टिल्ड वाटर, this is to make sure that all the soluble impurities are separated. अब यहाँ पे examiner question पूछ सकता है that why are we washing it? We are washing it for the soluble thing to go away. But if there is a soluble thing, name it. So if there is a sodium chloride in there, mention that we separate the sodium chloride. Alright? Alright, so we wash with distilled water, that's one thing. And after that, you say that dry in folds of filter paper. Okay? So these are 3 important points about separating things that are solid and solid. Okay, which salts can we evaporate to dryness, which do we have to crystallize? They will tell us. If there is a salt that you can dry, you can make crystals of, you can always evaporate to dryness. If they ask you for a dry powder, that's when you evaporate to dryness or evaporate to constant mass. But if they don't, then obviously you do. Al-Wakar, I will have to remove you, I'm really sorry, but you are constantly distracting others. Alright, so this is how you separate these things. Alright, So that is an important thing to remember when it comes to separating. अब आगे चलते हैं. What do you do if you have liquid mixed with solid? That is pretty straightforward. You do, if the solid is soluble, then you do distillation. If the solid is insoluble, you do filtration. So if the solid is insoluble, you do filtration, and you'll just say that filter the liquid. You don't need to give any detail, as I've already explained. But if it is soluble, then you have to do distillation. Acha, examiner ko again, they will give you some space for this. You don't have to write the whole distillation setup कि अच्छा boiling flask लगाएं, heat करें ये वो. Heat source की बात ज़रूर करना कि for example if you have the liquid is alcohol or if it's something that is organic liquid, then you have to know that it will be flammable. And so mention कि हम इसको electric heater से या इसको हम separate thermostatically controlled water bath से heat करेंगे. But if it's not something like that, you can just say कि एक्स्ट्रा इसको distill कर लें या do simple distillation and draw the setup, label the setup. That's good enough. A picture speaks 1,000 words. ठीक है, तो वो आपको डिटेल लिखने की, उसकी सेटअप की डिटेल लिखने की ज़रूरत नहीं है. इसेंशियल डिटेल होती है वो चीज़ें जो आपके जहन में होनी चाहिए कि अच्छा मैंने कौन सा सोर्स ऑफ हीट यूज़ करना है, मैंने इनको सेपरेट करते हुए फ्रैक्शनिंग कॉलम लगाना है या नहीं लगाना. ठीक है, दोज आर थिंग्स दैट यू मस्ट रिमेंबर. And of course, you have to make sure that the liquid boils before 100 degrees Celsius. Otherwise, you cannot use water to separate it. Okay, so that is how you separate liquids and solids. Now, what do you do if you have liquid and liquid? Now, again, you have two situations here. One is if the liquids and liquids are immiscible. If that is the case, then you do what is that thing called? Separating funnel. Okay. So separating funnel is used to separate two liquids that are not going to dissolve. And the examiner might ask क्यों dissolve नहीं हो रहे? इसलिए नहीं हो रहे क्योंकि उनकी density different है. इसलिए वो separate करने के लिए हमें, and you might want to use liquids like oil and water. That will make layers because they have different solubilities, they have different densities. But if they are miscible, then you will need to use fractional distillation. And again, mentioning fractional distillation is good enough. No need to write कि fractioning column होता है, उसमें glass beads होते हैं, वो ये करते हैं. No need to do any of that. ज़्यादा आपने detail देनी है, draw the diagram. Now, decanting might be a good choice if you don't have enough time और अगर आप डेली लाइफ में काम कर रहे हो. ठीक है, बट डिकैंटिंग इज़ नॉट अ गुड चॉइस इफ यू वर्किंग इन द लैब बिकॉज इट्स नॉट अ वेरी यूजफुल वे. सो यू हैव टू मेक श्योर कि डिकैंटिंग कभी भी आपने नहीं लिखनी एग्जाम में. आपके पास फिल्ट्रेशन इज़ द परफेक्ट मेथड, वी विल प्रेफर दैट. फ्रैक्शनल फनल भी कह सकते हैं. फ्रैक्शनल फनल आई हैव नेवर हर्ड दैट टर्म, बट इफ इट्स इन सम मार्क स्कीम देन ऑब्वियसली आई विल yield to that. Okay, what if you want to separate gas plus gas? This is something that most students don't really know of. Ravi is asking that draw करना ज़रूरी है. I think कि वो आपको choice देता है, but it's not really a choice because if you draw, you have a higher chance of getting good marks. So अगर उसने space दी हुई है, make use of that space. Draw करें, हाँ label ज़रूर करें. अगर आपने draw करना है label नहीं करना कोई फ़ायदा नहीं है. So make sure that if you're drawing a diagram, it doesn't have to be a very artistically beautiful. It's just something to show that you know what the setup is going to be. Don't spend too much time on the drawing. Do not spend too much time on the drawing. I've seen students waste a lot of time. वो shade करना शुरू कर देते हैं and it's very satisfying probably. So वो उसमें time लगा देते हैं. Don't do that. ठीक है, label ज़रूर करें. अच्छा, what do we do if we have gas and gas to separate? Then of course the only way to separate them is to first liquefy them. That is the best way of separating. आपके पास 100% separation होती है कि आप उसको liquefy करते हैं. Now liquefaction means that you're cooling the gas, and there is a very good application of that. Do you remember what was that when we used to like what you call liquefy करते थे? कहाँ पर liquefy करते थे? Do you remember? What was that? Guys, I'm asking you a question. कहाँ यूज़ करते थे? हेबर प्रोसेस. Hold on. I just reported a user to YouTube. और कौन था? हेबर प्रोसेस नॉट रियली. हेबर प्रोसेस में हम करते नहीं थे उनको लिक्विफाई. हम पहले बिफोर वी डिड द हेबर प्रोसेस हम उससे पहले हाइड्रोजन नाइट्रोजन को एयर से निकालते थे. फ्रैक्शनल डिस्टिलेशन ऑफ एयर इज वेयर वी गेट द नाइट्रोजन फ्रॉम. येस, ज़ेनब एंड ज़ैन, यू आर राइट. And that is when you first liquefy them, you cool the thing to a very low temperature, then you slowly heat them ताकि आपका fractional distillation हो जाए. यानी कि we have liquefaction which brings us back to this liquid and liquid setup, and then you do fractional distillation. That is how you separate gas plus gas. But if you don't want a very good level of separation, if you just want to test कि gases different हैं कि नहीं हैं, then we have a very easy method of doing it. Okay, and that method is that you use what you call diffusion. Okay, so diffusion is a very easy way of separating two liquids that are going to be two gases, that are going to be there, because these gases will have different MRs, and if they have different MRs you can easily differentiate between them based on their different MRs. Okay, so that is one way you can do this. All right, so diffusion, for example, if you want to detect अच्छा ammonia है और HCl है, which one is there? So you can obviously use litmus paper. एक setup बनाएंगे, ठीक है. उस setup के एक side पे हमारे पास ammonia है, HCl है, and they're both traveling. But if you have like two litmus paper, one is blue and one is red, ठीक है, तो आपको पता चल जाएगा that there is going to be one that turns blue first, and that is because ammonia has a lower MR, and then of course वो diffusion वाली सारी बातें इसमें आ जाएंगी. Okay, I will probably need a moderator. Anybody here who would like to help me out in this, because ये काफ़ी ज़्यादा लोग हैं and I don't want to spend too much time on this. All right, what if we have equal masses of gas? Doesn't matter. It is the MR that determines which gas comes first and which gas comes later. Okay, so Huzaifa, I'm making you a moderator. So देख लेना chat में, अगर कोई बदतमीजी करता है तो उसको निकाल दो, ठीक है. All right, so it is not the what you call mass of the gas that matters. It is the MR of the gas that matters. All right, so that is how you separate all of these things, और हमें उसके बारे में separation technique के बारे में at least पता चल गया है. The next thing that we have is how do you separate two soluble things? Like हमारे पास porous pot वाला, oh that is really easy. Porous pot क्या होता है? मैनोमीटर, फिजिक्स में आज आपका पेपर था, फिजिक्स याद है क्या मैनोमीटर क्या करता था? मैनोमीटर में आपके पास इस तरह, you have this setup, इसमें आपके पास लिक्विड्स होंगे, ठीक है. बाय द वे एग्जामिनर को पता लग गया कि भाई बच्चों को ये हर टीचर याद करा देता है, तो एग्जामिनर बहुत ज़्यादा अब इसके ऊपर क्वेश्चन नहीं देता. खैर, लेट्स सपोज हमारे पास इस साइड से कोई गैस आ रही है, ठीक है, और हम गैस क्या ला रहे हैं, हम ये पोरस पॉट यूज़ कर लेते हैं, और यहाँ पे एक डिफरेंट कोई सेटअप है एंड ऑल दैट, ठीक है. तो अब आपने एक चीज़ को ज़हन रखना है कि यहाँ पर जो भी गैस होगी, सो लेट्स सपोज ये इस तरह से है, ठीक है. अब हमने इसको ऐसे कनेक्ट कर दिया और समथिंग, मुझे एग्जैक्टली याद नहीं है सेटअप क्या था, बट इस तरह से होता है. तो यहाँ से एटमॉस्फेरिक प्रेशर आ रहा है. एटमॉस्फेरिक प्रेशर कहाँ से आ रहा है? ऑब्वियसली उसमें नाइट्रोजन है, ऑक्सीजन एंड ऑल दैट. देयर इज सम सोर्स ऑफ गैस हेयर, सो देयर इज अ गैस मिक्सचर इनसाइड. नाउ यू हैव टू रिमेंबर देयर इज अ गैस कमिंग इन, और अगर वो गैस ज़्यादा जल्दी आएगी तो ये गैस ज़्यादा पुश करेगी इसको नीचे को, तो द लेवल ऑन द लेफ्ट विल फॉल. और देयर इज ऑल्सो अ गैस गोइंग आउट, और अगर वो जल्दी वापस जाएगी तो अंदर गैस कम रह जाएगी, जिसका मतलब है द लेवल ऑन द लेफ्ट विल गो अप. इट इज़ ओनली अ वे ऑफ फिगरिंग आउट कि गैस अंदर जल्दी आ रही है या बाहर जल्दी जा रही है. तो उसका सिंपल सा तरीका है, इफ़ द गैस इज़ लाइटर देन एयर इट विल एस्केप फर्स्ट. बिफोर एयर कैन कम इन वो जल्दी से एस्केप कर जाएगी. अंदर वॉल्यूम कम रह जाएगी विच मीन्स द लेवल विल राइज. But if the gas is heavier than air, then it will take longer to go out, but air will come in that time. So the level on the left will go down. That's the only thing you have to remember. That if the gas inside is lighter, then the level will go up because it will escape first. ठीक है, दो चीज़ें रेस कर रही हैं. Air is coming in and the gas inside is going out. Thank you so much, Aksa. Good to see you here. Thank you so much. How's your school going? And I think you were also going for master, so congratulations on that. Alright, so there are two things here. One is the air coming in and the second is the gas inside going out. If the gas inside is lighter, it will go out first, which means level ऊपर चले जाएगा. If the gas is heavy, it will go out late, which means level नीचे आ जाएगा. That's the only thing you have to remember. Okay, and everything else will obviously just fall into place according to that. So that's the porous pot thing जिसके ऊपर usually question आता है. अब chromatography की बात कर लेते हैं. Chromatography is basically this setup. You have to पेपर chromatography आती है, जो भी different types of chromatography है ना, जैसे TLC होती है या GC होती है, that's not in our syllabus. उसको पढ़ने की भी ज़रूरत नहीं है. कुछ I don't know, I've seen notes जिनमें उनकी details होती है. We don't need them. अस्सलाम वालेकुम अब्दुल्ला, good to see you here. Alright, so first thing, रबिया क्या समझ नहीं आया मुझे बता दो. So first thing, you have to make sure that you have a baseline. This is the starting point. यहाँ से liquid जाना शुरू करेगा. You put the spot here. I'm going to put a couple of spots. Okay. And then there's going to be some solvent front after this has been done. अच्छा, जब आप इसको एग्जाम में बनाएंगे, सबसे पहले आपने लिखना है that this baseline should be drawn with pencil. It's super important that you draw the baseline with pencil, not with anything else, because we need to make sure कि dissolve नहीं होता. अच्छा, I'll come back to the porous spot thing. Then there are two ways you use chromatography for. One is to know if something is pure or not, and second is to match different things. ठीक है, दोनों में आपको chromatography का use आना चाहिए. If you want to check whether this is what you call pure or not, then you have to make sure that it has to give one spot. That's it. It has to move and it has to give one spot. If it doesn't move, it's insoluble. आपको कोई फायदा नहीं होगा. Remember this thing. If it doesn't move, it's insoluble. Pure chromatography has failed. We will need to use a different solvent. If it does move and gives us one spot, that means it's pure. If it does move and gives us multiple spots, that means it's impure. ये तीन categories हैं हमारे पास, इसके अलावा कुछ नहीं. Fourth, if it does move and goes away, goes colorless, then that means you have to make sure that you use a locating agent. So 4 categories again, दोबारा बता रहा हूँ. First is, if it doesn't move, that means it's insoluble, use a different solvent. Okay. Number 2, if it does move and give us one spot, that means it is pure substance. It moves to give multiple spots, it's impure. It moves and goes colorless, you use a locating agent. ये 4 categories हैं. There is no non-solvent that will dissolve graphite. So, and the reason is really simple. Graphite is too heavy, the structure cannot be broken that easily by liquids. तो इस वजह से वो room temperature पे कोई solvent graphite को dissolve नहीं करता. अच्छा, then we have these, this is called solvent front and we use this to figure out the RF value. अच्छा, तो मैंने chromatography के आपको 2 uses बताए थे. पहला यूज़ क्या बताया था कि इफ़ यू वांट टू चेक इफ़ समथिंग इज़ प्योर और नॉट, और उसमें 4 कैटेगरीज हैं, मैंने आपको बता दी. सेकेंड इज़ इफ़ यू वांट टू कंपेयर और आइडेंटिफाई अ पर्टिकुलर सॉलिड. फॉर एग्जांपल पैरासीटामोल है. पैरासीटामोल इज़ अ ड्रग दैट इज़ यूज्ड फॉर परफॉर्मेंस एनहांसिंग. जो ये हॉर्स रेसेस होती है ना, तो उसमें लोगों ने people bet on those, there's gambling in there, so people try to win a lot of money by using simple drugs like paracetamol. अब घोड़े को अगर आप पैरासीटामोल का इंजेक्शन दे दोगे वो तेज़ भागता है, सिंपल. तो अब ऑब्वियसली इट्स नॉट अलाउड. सो हाउ डू यू नो कि ये पर्टिकुलर जो रेस हॉर्स है इसको पैरासीटामोल उन्होंने दिया कि नहीं दिया? सो बड़ा सिंपल सा तरीका है. यू टेक अ प्योर पैरासीटामोल. पहले तो आपको प्योर पैरासीटामोल चाहिए. ठीक है, यूज़ कर लिया. लेट्स सपोज दिस इज प्योर पैरासीटामोल. ओके, नाउ इफ इट इज़ अ प्योर पैरासीटामोल और मैं इसको क्रोमेटोग्राफी सेटअप करता हूँ, लिक्विड लेवल हैज़ टू बी बिलो द बेस लाइन. थोड़ी देर बाद मैं देखूंगा कि यहाँ पर मेरे पास ये पैरासीटामोल का ही लेवल आ गया. आई एम नॉट श्योर अब्दुल्ला, यू हैव टू कंसल्ट अ डॉक्टर फॉर दैट. नाउ लेट्स सपोज दीज आर डिफरेंट हॉर्सेस टेकिंग पार्ट इन द रेस, और हमने उनके ब्लड सैंपल्स ले लिए और यहाँ पे रख दिए. नाउ ऑब्वियसली देर ऑल गोइंग टू गिव अस सम मल्टीपल स्पॉट्स. लेट्स सपोज इसमें हमारे पास मल्टीपल स्पॉट्स आ जाते हैं. तो हमें इससे क्या पता चल रहा है? फर्स्ट ऑफ ऑल वी नो दैट दे आर ऑल इम्प्योर. सेकेंड, दे आर ऑल सॉल्युबल. थर्ड, we have two ways of knowing which one has used paracetamol. Does anybody know the two ways? Now, the horse that has used it is B. Okay? But how do we know? There are two ways of doing that. One is a really simple RF value. You take RF value, and in the exam, if you're going to talk about RF value, you have to give the full formula. Okay? So you have to say, I'm so sorry, Abdullah, you have such a sad life. Alright, so one is RF value, और RF value में क्या होता है कि आपके पास you have this distance traveled by solute divided by distance traveled by solvent. Yes, I will upload it on the channel after the session. Okay, so you have to mention the formula अगर आप RF value की बात कर रहे हो. Okay, अब्दुल्ला बिलाल क्या कर रहे हो यार? ठीक है, कॉमेडी का करियर आपका ना, आपको क्लास में ही पता लग गया था कि फ्लॉप हो गया, तो ज़रूरी नहीं है कि आप यहाँ पे भी यही गन मचाओ. ऑलराइट, कमिंग बैक. सो आपके पास RF वैल्यू जो होती है ना, वो डिस्टेंस ट्रैवल बाय सोल्यूट डिवाइड बाय डिस्टेंस ट्रैवल बाय सॉल्वेंट, एंड यू हैव टू राइट द फॉर्मूला. बट दैट इज़ अ मोर एडवांस्ड मेथड अगर आपने देखना है कि ये और वो दो सेम चीज़ें कि नहीं है. बट देयर इज़ अ मच ईजियर मेथड, स्पेशली अगर आपको उसने सिर्फ आइडेंटिफाई करने का दे दिया. अगर आपको लेट्स सपोज वो डायग्राम दे देता है, तो तब आप क्या करते हैं? सो देन यू डू अ हॉरिजॉन्टल लाइन टेस्ट. यू ड्रॉ अ हॉरिजॉन्टल लाइन, और ये वैसे तो MCQs में ज़्यादा यूजफुल होता है, बट मैं वैसे आपको बताता हूँ दैट इफ यू आर ऑन द सेम लेवल, दैट मीन्स कि वो सेम सब्सटेंस है. डू नॉट से कॉम्पाउंड, डू नॉट से एलिमेंट, they are the same substance, because it can be different things. Paracetamol एक compound है, but it doesn't have to be something that you already know कि वो क्या है. ठीक है, it could very well be some element as well. तो इस वजह से we will not mention any of this, we'll just use the general word substance. So these are two ways of knowing कि chromatography में जो चीज़ है वो क्या है. So chromatography के दो uses हो गए. One is identifying liquids or identifying substances, sorry, in which case you need a pure thing and the mixture, and you check the RF value. And second is knowing if something is pure or not based on simply dissolving and then getting one spot. तो हमारे पास ये दो केसेस हैं, और उनके अंदर फर्दर भी मैंने आपको डिटेल दिया. Alright, somebody wanted to know कि ये कैसे काम करता है. Again, let me clarify that in this setup there is a gas inside, there is a gas mixture inside. I'm talking about this region, this red region. इस region में से गैस ने बाहर आना है. Porous spot है ना, this is the porous spot. Okay, and the air outside has to come in. So दो चीज़ें, either the gas inside will go out faster or the air outside will come in faster. या air जल्दी आएगी या gas inside जल्दी बाहर जाएगी. अगर gas बाहर जा रही है, इसका मतलब है उसका MR कम है. हाइड्रोजन हो सकती है, अमोनिया हो सकती है, मीथेन हो सकती है, जिसका MR कम है वो जल्दी बाहर चली जाएगी, लेवल ऊपर चले जाएगा. तो if the gas inside is lighter, the level will go up. अच्छा, अगर the gas inside is heavier, like sulfur dioxide है या carbon dioxide है, then air will come in faster, which means it will push the level down, and that is how the porous spot thing works. Alright, I don't really have any notes, but I've shared a couple of documents. वो उनमें different बातें discuss हुई हैं, तो आप वहाँ से देख सकते हो. ऑल्सो आई हैव अपलोडेड अ वीडियो ऑन दैट व्हाट यू कॉल मेजरिंग रेट, वो भी ज़रूर देख लीजिएगा. आई विल शेयर द लिंक हेयर एज वेल in case you need to use it, because rate वाला अभी मैं करना नहीं चाह रहा उसको सारे का सारा. Zainab is asking, why are we inverting a beaker? We are inverting a beaker to just make sure कि the gas doesn't escape बाहर को. we're just making sure कि वो उसके अंदर ही रहे, ठीक है. And yes Rabia, it is because of the pressure difference. Inverse relation है या नहीं है, I am not really sure. मुझे mathematical equation बनानी होगी इसकी. अस्सलाम वालेकुम मूसा. Can you share the documents? They're in the rapid revision group, so आप वहाँ से उनको देख लो. Okay. Ali Hussain is asking which chapter is decanting and centrifuging from. They're in the what you call separation technique wala, but we don't really need to go into that, because decanting and centrifuging are usually not a perfect technique, which is why we try not to use them in our exam. अच्छा खैर, सो हमारे पास प्योरीफिकेशन और सेपरेशन वाला सारा हमने बात कर ली. और डेली लाइफ के बारे में वो 1 मार्क का क्वेश्चन पूछ सकता है कि कहाँ पे उसकी ज़रूरत है और क्यों ज़रूरत है, तो वो हम वहाँ पर बता देंगे. अच्छा, उसके बाद हमारे पास आ जाते हैं ये एक सेक्शन 1.3 ऑफ द सिलेबस इज़ वेरी वेरी इंपॉर्टेंट. इसके ऊपर 2 क्वेश्चन ज़रूर आते हैं, विच मीन्स यू हैव टू रीड इट एंड मेमोराइज इट. इसको एग्जैक्टली ऐसे ही याद करना है. ऑलराइट, सो दैट्स वेरी इंपॉर्टेंट. सो फॉर एग्जाम्पल हमारे पास यहाँ है, डिस्क्राइब द यूज ऑफ एक्वासोडियम हाइड्रोक्साइड एंड एक्वासोमोनिया टू आइडेंटिफाई द फॉलोइंग कैटाइंस. कैटाइंस एनाइंस के ऊपर मैंने एक वीडियो बनाई हुई है. लेट मी शेयर दैट एज वेल इन केस एनीबडी वांट्स टू रिव्यू इट. आई थिंक दैट विल रियली हेल्प आउट, क्योंकि आई हैव ट्राइड नॉट टू यूज अ टेबल. टेबल से तो अल्लाह जानता है आज तक किसी को नहीं याद हुआ, ठीक है. Hold on, let me see. Salt analysis. Just a minute, guys. Yep. So this is a useful video. मैंने ट्राई किया है कि आप लोगों को easily याद हो जाए इसको देख के, ठीक है. सो सॉल्ट एनालिसिस, इसमें से आप देख लीजिएगा छोटी सी वीडियो, एंड इट शुड हेल्प यू आउट व्हेन इट कम्स टू फिगरिंग आउट कि अच्छा कैटाइंस और एनाइंस को टेस्ट कैसे करना है, उनको याद कैसे करना है, ठीक है. सो दैट्स दैट. उसके बाद हमारे पास डिफरेंट गैसेज हैं, 6 गैसेज इन आवर सिलेबस, एंड यू नीड टू नो हाउ टू डिफ्रेंशिएट बिटवीन देम, हाउ टू टेस्ट देम. ऑक्सीजन और हाइड्रोजन वाला मिक्स नहीं करना. ऑक्सीजन यूजेज ग्लोइंग स्प्लिंट एंड हाइड्रोजन यूजेज लाइटेड स्प्लिंट, ओके, और बर्निंग स्प्लिंट. अच्छा, फिर हमारे पास एनाइंस का टेस्ट है. एनाइंस के टेस्ट भी हमारे पास एक नया ऐड हुआ है, सल्फाइड वाला, ठीक है. बट अदर देन दैट हमारे पास ये सामने है. व्हेन यू हीट सल्फाइड विद एन एसिड इट रिलीजेस सल्फर डाइऑक्साइड, एंड सेकेंडली सल्फाइड ऑक्सीडाइजेज इन द एयर टू सल्फेट, और सल्फेट का टेस्ट हमें पता है. अच्छा, सिंपल सी बातें हैं. बेरियम का नाम आने का मतलब ये है कि वो सल्फाइड या सल्फेट का टेस्ट करना चाह रहा है, ठीक है. बेरियम नाइट्रेट को यूज़ ही वो इसलिए करता है क्योंकि वो वाइट प्रेसिपिटेट देता है. सिल्वर नाइट्रेट का मतलब ही ये है कि वो हेलोजन का टेस्ट करना चाह रहा है, ठीक है. IGCSE पीपल, यू नीड टू नो द कलर ऑफ ब्रोमाइड, बट O लेवल्स पीपल डू नॉट नीड टू नो द कलर ऑफ ब्रोमाइड. ब्रोमीन का कलर सबको पता होना चाहिए, और वो है ऑरेंज. फॉर द लास्ट 2 years दे हैव यूज्ड ऑरेंज, दे हैव नॉट यूज्ड ब्राउन, दे हैव नॉट यूज्ड रेड ब्राउन और एनीथिंग. दे प्रेफर ऑरेंज, सो वी विल वर्क विद ऑरेंज. लेकिन आप अगर रेड ब्राउन लिख देते हो, आई डोंट थिंक वो आपके मार्क्स काटेंगे. बट यू हैव टू रिमेंबर दैट ब्राउन सोल्यूशन इज़ फॉर आयोडीन एज वेल एज ब्रोमीन, तो इस वजह से हम ब्रोमीन के लिए ऑरेंज लिखते हैं और आयोडीन सोल्यूशन के लिए ब्राउन सोल्यूशन लिखते हैं. आयोडीन के 3 कलर्स हैं. इन वेपर इट इज़ पर्पल, इन सॉलिड इट इज़ ब्लैक, और लिक्विड का तो मैंने आपको बता दिया, इट्स ब्राउन. ये कलर्स वगैरह के लिए मैंने एक PDF आप लोगों के साथ पहले भी शेयर की थी. होल्ड ऑन, लेट मी लुक फॉर इट. आई थिंक यहीं पे कहीं पे होगी. आई विल शेयर दैट एज वेल बिकॉज आई थिंक इट्स क्वाइट यूजफुल. यस, ये हमारा सेशन था जनवरी का. इसमें हमने सारा एवरीथिंग यू नीड टू मेमोराइज वाली बातें की थी. जो मेरा यूजुअली सेशन होता है ना सिलेबस का, उसमें आई ट्राई टू गेट दैट आउट ऑफ द वे अर्लियर ऑन. सो दिस इज़ द कलर्स एक्स्ट्रा दैट यू शुड रिव्यू. एक दफ़ा ज़रूर इस डॉक्यूमेंट को देख लेना. सिमिलरली सॉल्ट प्रेप के ऊपर कुछ लोगों को इशू था, सो सॉल्ट प्रेप का भी ये रिव्यू कर लेना. ये डॉक्यूमेंट नोट्स हैं, सो सॉल्ट प्रेप के. सॉल्ट प्रेप में मेन चीज़ जो है ना वो आपको है कि 3 कैटेगरीज हैं सॉल्ट प्रेप में. आई रिव्यू इट, एक दफ़ा मैं ओवरव्यू दे देता हूँ हाउ टू प्रिपेयर डिफरेंट सॉल्ट्स, क्योंकि इसके ऊपर काफ़ी लोगों को इशू आता है. डिस्क्राइब द केमिकल टेस्ट फॉर वाटर. डज एनीबडी नो द केमिकल टेस्ट फॉर वाटर? व्हाट इज दैट? There are 2 tests that you need to know about. One is cobalt 2 chloride, which goes from blue to pink, and the second is copper 2 sulfate, which goes from white to blue. Okay, so copper 2 sulfate goes from white to blue, and cobalt 2 chloride goes from blue to pink. Those are the 2. Yes, बिल्कुल ठीक कह रहे हैं आप लोग. Those are the 2 that we need to check about or know about. ठीक है. अच्छा, अगली चीज़ सॉल्ट प्रेपरेशन. आई क्विकली गो ओवर इट, ऑल्दो इसके ऊपर मैंने आज भी एक वीडियो अपलोड की है तो वो आपको काफ़ी हेल्प आउट करेगी. बट सॉल्ट प्रेप में हमारे पास 2 चीज़ें हैं जो हमें याद करनी है. फर्स्ट वन इज़ कि आपका सॉल्ट, आपने 2 सवाल पूछने हैं. फर्स्ट वन, इज़ द सॉल्ट सॉल्युबल और नॉट. अगर तो है तो उसकी तरीका और होगा, नहीं है तो तरीका और होगा. एंड देन सेकेंड थिंग यू हैव टू नो इज़ इट स्नैप. अगर वो स्नैप है तो आपका तरीका और होगा, और स्नैप नहीं है तो तरीका और होगा. एंड दोज आर द 3 मेथड्स जिससे कोई भी सॉल्ट बनाया जाता है. दोज आर द ओनली 3 मेथड्स दैट आर रेलिवेंट टू आवर वर्क. सो इफ इट इज स्नैप विल डू टाइट्रेशन. टाइट्रेशन पे मैंने आज सुबह 7-8 मिनट की एक वीडियो अपलोड की है. मेक श्योर कि उसको भी देख लें, उसमें पूरी डिटेल है, लेकिन मैं आपको अभी रिव्यू दे दूंगा. स्नैप में अगर वो स्नैप सॉल्ट नहीं है, सॉल्युबल है, स्नैप नहीं है, देन वी यूज़ व्हाट वी कॉल द मिक्सिंग मेथड. ये मिक्सिंग मेथड से एग्जामिनर को कुछ पता नहीं लगेगा, टाइट्रेशन से पता लग जाएगा. एंड इफ इट इज़ नॉट सॉल्युबल, इफ इट इज़ इनसॉल्युबल, देन वी यूज़ व्हाट वी कॉल प्रेसिपिटेशन मेथड. ठीक है, सो हमारे पास ये 3 सेटअप हो गए. नाउ हाउ डू यू वर्क विदाउट टाइट्रेशन में? व्हाट यू हैव टू मेक श्योर,